Till now, for the solution of the simultaneous linear equations, we have used these direct methods. Today we are going to see the indirect methods, that is the Jacobi method and the Gauss-Seidel method. This Gauss-Seidel and the Jacobi method we are going to see. These are iterative methods, so the result of the first iteration will be taken to the second iteration. In the Jacobi method, we have to satisfy this particular criteria. So let's see this criteria with an example. Suppose I have these three equations. So what is the criteria? The criteria says that in order to find out a value of a particular variable, its coefficient should be greater than the summation of the other two. Suppose in this particular equation, if I want to calculate the variable x, in that case its coefficient a1 should be greater than the summation of the other two. Similarly, from this equation, if I want to calculate my y, in that case the coefficient of that particular variable has to be greater than the summation of the other two. Similarly for this. Hence, if I have an equation of this sort, over here as you can see, z is having the highest variable coefficient. So I am going to, from this equation, I am going to consider z. Please do see that this is not y, this is z. I have made a mistake while writing. This is z. Okay, so this is z. From this equation, since the coefficient of y is having the largest value, so I am going to consider this as y. Similarly, from this equation, I am going to take the x. So what happens in the Jacobi method is that the variable whose value I want to find out, I will keep that on the left hand side, and everything else will be shifted to the right hand side. So from this particular equation, since I'm assuming that this x coefficient is larger, only this will remain on the left hand side. Everything else has been taken on the right hand side. See. Now, once we do this, what we do is that now I don't know what is the value of y, x. I have no idea. I only know about ABCD. As you can see over here, I have no idea about what is the value of y, z. So when I have no idea, I have to start somewhere. The starting point will be putting x, y, z all equal to 0. So what will I do? In the first equation, since I'm finding out x, so what will I do? I will put y and z to be 0. If I put y and z to be 0, then it becomes 3 by 10, so x becomes 3.3. In the second equation, while calculating y, I am going to put x and z to be 0. So again, minus 3 by 10 means 3 by 10 is 0.3. In the third equation, please pay attention that this is not y, this is z. I am again going to put x and y to be 0, and over here also I got to be 0.3. So from the first iteration, what do I have? I now have some value of x, y, and z. Are they the answer? No, they are not the answer. They are just the first approximation. What will I do in the next one? I'm going to put this x, y, z again on this equation, and I'm going to find out my next iterated value. So now I'm not going to put my y to be 0 and z to be 0 in this equation. Now I'm going to put my y to be 0.3 and z to be 0.3. And then I will find out what is my x. Similarly, over here I'm going to put x to be 0.3, z to be 0.3. I'm going to find y. Again, I'm going to put x to be 0.3, y to be 0.3. I'm going to find z. So in the second iteration, I'm going to put the values again, and I'm going to find out my new x, y, and z. So initially I took x, y, z to be 0. I found out this first approximated value. Then I took them and I found out my second approximated value. Then I will put this and I find out my third approximated value. And I will keep on doing it till one of the variable is having suppose I have to see up to 3 decimal places. So I want to see up to 3 decimal places. If in the consecutive equations the 3 decimal places remains the same, in that case I will stop the iteration. So I will keep on continuing it. So this is Jacobi method. So in the Jacobi method, what we do is that since we do not know the initial value, we will initially consider my x, y, and z to be 0, put them in the equation, find out the approximated value, then we'll take them and again put it back to the equation and find out the second approximated value, and keep on doing it till we have two consecutive values to be same up to 3 decimal places or 4 decimal places depending upon your question. So this is the Jacobi method. Please keep in mind that you have to first verify this condition. If this condition is not satisfied, then you cannot find out. Now what happens in the Gauss-Seidel iterations? See, over here also we have to first do the same verification. But over here what happens is that initially, yes, I took my x, y and z to be 0. But on each iteration I will be updating the value. Let me show it to you. Suppose these are three equations. These are the three equations. So from the first equation I can see this 83x plus y. From here I can take out my x because this is having the highest coefficient. From here I can take out my y. See, this is my y. And from here I will take out my z. Because they are satisfying what condition? This particular condition. Just do it yourself and see. Okay. Now, in the Jacobi method, what did I do? I put y and z 0 over here, found out x and z 0, found out y, x and y 0 and found out z. Isn't it? But here I will not do this. Here what will I do is that I will, in the first x, I will put y and z to be 0 because I do not have any value for them. So I'll put y and z to be 0. When I put y and z to be 0, I have now some value of x which is 1.145, isn't it? So now I do have a value of x. So in the second iteration, I will not put my x to be 0. I will put my x to be this. But do I have any value of z? No. So I will keep it to be 0. As you can see, I've done this. And now I have found out my y. In the third iteration, see, I do have a value of x. How? Yes, here it is. I do have a value of y. How? Here it is. Now since I have x and some value of y, I am not going to put 0 over here. I am going to put them. And I am going to calculate my z. So I have my first iterated value. Once I have the first iterated value, I am going to use the same process. Now again I am going to put y and z from here to this equation and calculate my x2. I will put this x2 and z and calculate y2 and then z2. And I will keep on continuing here. So up to how, if the question asks you 3 decimal places, so you will see the 3 decimal places. So two consecutive iterations should have similarity in the 3 decimal places, limit and even stop. So the only difference between the Jacobi method and the Gauss-Seidel method is that in the Jacobi method, I was taking them to be constant. In the first iteration, all of them were 0. Then I took the values and put them back on the second iteration. But in the Gauss-Seidel method, they are updated at each step. So it is quicker. It gives you a result in a very quick iterations. So this is better than my Jacobi method. I will also provide you with the supplementary videos. Don't worry. Thank you.